Blocks are quite literally the building blocks of the entire blockchain. In this video, we'll explore what a block is and define some of the important terms related to the blocks. A block is a container that holds a list of transactions to be added to the blockchain. As we've seen, a blockchain is a shared ledger containing a list of all records that happen throughout the network. If we were to let this run on forever as one huge list, we'll end up with an enormous list of transactions. This would get really difficult to work with or manage. To give us more control over this list, the blockchain is split up into smaller sections known as blocks. As transactions are made, they are bundled together into these blocks and added to the blockchain. This breaks up the ledger into smaller bite-sized pieces that we can use to manage the entire system more efficiently. Along with these transactions, blocks also hold some other interesting information. Let's look at the details of a single block more closely. While transactions are held in the body of a block, other information is held in part of the block known as the block header. This header contains extra information that includes details about the structure of the data inside the block. The hash of the previous block, the time the block was made, the Merkle root, and the nonce all sit inside the block's header. There were some new terms in there, so let's walk through them now. The previous block's hash is what it sounds like. It's the hash value for the block that comes directly before the given block in the chain. Having this connection links the blocks together by allowing us to always know what block comes before and after any block on the chain. This is what forms the basis of the entire blockchain. The time the block was created is also held inside the header. This way, we know exactly when each block was made. That helps us know when certain transactions took place and can help us catch things like when someone may have tried to spend the same money twice. With this information, we can decide which transactions were valid based on which happened first. This timestamp is the blockchain solution to the double spending problem we mentioned earlier. The Merkle root is a hash that represents every transaction inside the block. To get the Merkle root, pairs of the transactions within the block are repeatedly hashed together. Each pair results in a single hash. Then the hash of two pairs of transactions are again hashed together over and over again until you are left with a single hash value. Given that final hash value, known as the Merkle root, you can now reverse the hashing to reconstruct the entire set of transactions from the original block. The nonce has more to do with some topics we'll cover later related to what's known as mining. As a quick introduction, the nonce is an arbitrary number that can only be used once. When creating a hash for a block, not just any value will work. The system requests a very specific hash value that starts with a certain number of zeros. These extra constraints make the hash more difficult to find. To find that value, you combine all the block's data with this nonce to try to generate the correct hash value. Computers guess this nonce over and over again until finally they come up with a value that gives us a hash that meets the constraints. Exactly why this is important might not be so clear right now, but we'll cover this in more detail when we go over mining. The number of zeros that are requested to solve this problem is known as the block's difficulty. If more zeros are needed, that's a more specific request, so it's more difficult to find. If you ask for more zeros, block difficulty goes up. If less zeros, block difficulty goes down. Another attribute a block has is known as the block size. The block size is the amount of space a block has to hold information. Like your computer or phone, there are limits to the amount of space on a block. This amount of space in a block is decided by the developer and helps control things like how long it takes for a block to fill up or how many blocks will be on the chain. Once decided, this will be the same for every block on a given chain and can only be changed by making updates to the software. If the block size were 1 megabyte, that means that once this limit is reached, the block is full, and it's time to start generating a new one. Another piece of information you'll find on a block is its hash value. This hash value is a result of running all the block's data through a SHA-256 algorithm. This hash will be the unique fingerprint we can use to identify the block in the future. Remember, if data changes even slightly, this will generate a completely new hash value. That means if a transaction changes on the block, this hash will also change. This is really important because it lets everyone know when a block has been tampered with. This makes the blockchain a secure way to keep a history of information that you can be sure hasn't been changed without you knowing. That's the basic concept of a block, and some terminology to go along with it. There's not really more to it than that. Later, you'll learn how this fits into the system and how you can look through the data inside the block yourself. But overall, this is most of the concept you'll need to understand about what a block actually is.